Hello everyone, good morning, good afternoon and good evening. So today I will talk about IP address, but this is actually the second tutorial on IP address. In the first tutorial I already have posted, many of you maybe already watched that video, and this is the second tutorial on IP address. And in this video or in this tutorial I will discuss more focusing on the classful and the classless IP address, then which part of an IP address is the network address, the host address and the broadcast address, and then I'll discuss about the private IP addresses. And another important concept is the mask or subnet mask. And then finally I will also show you how to by using a small lab to see like what is the default mask and how we can change the mask by using a lab. Okay, so let's get started. So for example, this is an IP address 192.168.10.10. So the computer, or as a network engineer or an IT professional, we need to know which part of this IP address is the network address and which part of this IP address is the host address. That means every IP address has some part of, or one part is used for network identification or network address, and another part is to identify a host device or the host address. So in this case, like 192.168.10.10, so for example, the 10 is the host address and the 192.168.10 is the network address. But we need to understand, how actually computer know which part of the network address and which part of the host address. We also need to know because we need to design our networks, so we need to troubleshoot the networks. So ultimately we also need to know the IP address and what part of the IP address and what part of an IP address is a network address and what part of the IP address is the host address. So to analyze the IP address or to know all of these, so we actually has the two different approach. So one is called the classful and another is called the classless. So two different approach to analyze the IP addresses. So one is the classful IP address, another one is the classless IP address. So we will start first with the classful IP address and then we will finish the classless IP address. So in this video I will go through the details of the classful IP address and the classless IP address. Okay, so in classful IP address, so each of the IP address or the number of IP addresses we have is actually divided into different classes, and these classes are called Class A, Class B, Class C, Class D, and Class E. So now for example, so we have all the IP addresses in IPv4 addresses, which is 2 to the power 32, right? So in the previous video I discussed about that, right? Why 2 to the power 32? Because the number of bits in IPv4 address is 32. So we have around 4.3 billion IP address, which is 2 to the power 32. So now let's see how actually this Class A, Class B, Class C, Class D, and Class D actually came into the picture, right? So consider we have a bucket, and or consider this circle. We have all the IP addresses here. So what actually the expert did in the beginning when the IPv4 address invented, so they actually make this whole bucket into the two group. So one is the Class A, another is the Class B, And then they said, okay, how we can identify the class A and class B, or how a computer identify that this IP address is from class A and this IP address from class B. So they said, okay, then the class A will start by 0 and class B will start by 1. That means the leftmost bit of the class A is always 0 and the leftmost bit of the class B is always 1. Okay, so that means the leading bit, so that means the leading bit is always 0 in class A. So when we consider or we analyzed an IP address as a classful approach. Okay, so in class A, so out of 32 bits, 8 bits is used for network address, and 8 plus 8 plus 8, that means 24 bits is used for host address. So that means the valid network address range is 1.0.0.0 to 126.0.0.0. Okay, so now let's see how actually we get 1.0.0.0 to 126.0.0.0. So the idea is, so 1.0.0, this is the decimal numbers, right? So we can convert all the decimal numbers. So the first or the leftmost decimal number is 8-bit binary, 8-bit binary, another 8-bit, another 8-bit, that means total 32 bits. And we said the for class A, the first or the leftmost bit is always 0. That means the leftmost bit of the leftmost byte is always 0. So if it is always 0, that's what I said, I wrote here the 0 and 0. This 0 is actually the leading bit 0. So we have 7 bit more, and that 7 bit could be, that 7 bit could be, so this 0 is the leading bit 0, and this 7 bit could be all 0 or all 1. So if it is all 0, that means 80, so the decimal of this 80 is 0, and leading bit or the leftmost bit is 0, and the 1 which is 127. So now the question is, why not 0 to 127? So the idea is here 127 they keep as a reserved. 127 is for reserved. So 1 less than 127 is actually 126, and all 0 are 0, so we should start from 1. So 1 and the other than or the less than 1 less than 127 is 126. So the range for class A networks is 1 to 126, and all other bits are host bit. So again, in a class A networks, network bits are leftmost 8 bits, and the remaining 24 bits is used for host. Okay, so the one here, the range or the valid network address in class A is 1 to 126. The reason we said the leading bit is always 0, so the leftmost bit is always 0. That means the other bit could be 0 or 1. So if other bit is 0 and 1, all the 0 are 0, and all the 7-bit 1 is 127, and then 127 they kept for reserved. So that means the number before the 127 is 126, and 1 to 126 is the valid network range for class A. Okay, so now they start thinking about, okay, if we make only the 2 class, and each of the class is only 8-bit for networks, then we are getting only a small amount of networks, and each network is way bigger. So that means each network could have 2 to the power 24 hosts. But this is not all the case. So maybe we might need smaller networks and more networks. So then they decided, okay, instead of having the 2 classes, so make it more classes. Then they divided the class B into 2 classes, class B and the class C. Now again the same question. So how we can identify class B and class C, because both are 1. Then they added again the 0 and 1. So they added the 0 and 1. So the 0 is the class B and they added 1 to the class C. That means 1 0 is now the leading bit for class B. That means 1 0 is fixed for class B. And another key part, important part in the class B is, in case of class B, 2 leftmost byte is the network address and the 2 rightmost byte is for host address. So that means now we can have 2 to the power 16 and the 2 to the power 16. That means the 16 bits for host and 16 bits for network address. So we are getting more networks, but comparatively smaller network than the class A. So what is the valid range of the class B? So the valid range for class B is 128.0.0.0 to 191.255.0.0. Okay, so now let's see how again we get this valid range. So we said 10 is the fixed for class B, so which is the 2 leading bits are always 10. So the 2 leading bits are always 0. So if 2 leading bits are always 0, that means 10 and 10, so we have the remaining 6 bits. Remaining 6 bits could be 0 to 1. Any number 0 or 1. So all could be 0 or all could be 1 or 0 and 1. Okay. So if these all are 0, that means 1 0 0 0 0 0 0, that is 128. And we saw this conversion very easily in the previous video, right? So how can we convert it? And then 1 0 and all are 1, which is 193. So 128, and if you add this part, so you can get 191. So this 10 is the leading bits and which is always fixed, so which is 10, and the remaining bits could be 0 and 1. So this is how we get 128 to 191. And the second byte, all could be 0 and all could be 1. So if all is 0, that is 0, and all are 1, then 255. So that's why we get the valid range for class B is 128.0.0 to 191.255.0.0, which is the valid range of networks in class B. So now let's see how and what is the properties of the class C. Now they again start thinking, okay, we extended, we created one more class, but we need another class which is even, we need more networks but even smaller size of the network. That means number of hosts could be even smaller. So then they actually divided this class C, again the two part, the class C and the class D, and then they added in again to separate them, they added 0 and 1. So now the leading bit for the class C is 100. So this 100 is now the leading bit, and which is fixed for always any IP address in the class C. So now the valid network address for class C is 192.0.0 to 223.255.255.0. So again, let's see how we get 192 to 223. So we said this 110, these leading bits are fixed, right? So 110 110, these leading bits are defined. This can never be changed. So the other 5 bits could be 0 or 1. So if all other 5 bits are 0, then we get the 192. That means 1 1, then the 0 0 0 0 0 0 is 192, and 1 1, then 0, then 1 1 1 1 1, so which is 2 2 3. So this is how we get the valid range is 192 and 223, and the remaining 3 bits and remaining 2 bytes so are from 0 to all 1, so 0 to 255 and 0 to 255. So again, the class C has 3 bytes, 3 leftmost bytes are for network address. So we are getting 2 to the power 24 of networks in class C, and the host address is only 2 to the power 8. So we will see later. I will give you another summary later when we get understand all the classes. Okay. So now they again divided the class D into the 2 parts. So class D and class E, and then they added the 0 and 1. So when they added the 0 1 to separate them, so we got the 2 more classes. One is class D, another one is class E. So class D IP addresses are mostly used for multicasting, and class D IP addresses are mostly used for research purpose. So the key understanding, we have to have clear idea on class A, class B, and class C. Okay, so let's summarize what we learned till now. So we have the class A, and class A networks has 8-bit for network address and 24 bits for host address. Okay, so if only 8-bit for network address, we are getting number of network is 126, because one leading bit is fixed, so it's always 0, and number of host per network we are getting this amount. Okay, so it's very big numbers, right? So each of the network could have this number of host per network, each network. That means the class A is the biggest network, so each of the class A network is big. Okay, and then the class B is 2 byte for the network address and the 2 byte for host address. So the 2 byte for network address and 10, that means 2 leading bit is always fixed. So we are getting around 16,000 of networks in class B, and we are getting 65,000 of IP addresses in class B, or these types of host for each of the network in class B. And in the class C, we have 3 bytes, 3 leftmost bytes are the network address, and only the last byte is the host address. So the number of hosts is 254 we can have, and the number of networks we could have these big numbers, right? So that means the reason is, again, the 110 is the fixed. These leading bits are always fixed for the class C. Okay, so it's some millions of networks, right? Here is also some millions of networks, so host. So the class, again, the class A is the largest networks. Each network has millions of the host, and class C is the smallest networks. Then that means each network could have around 254 hosts, but this give us to get the many of networks. Okay, so now we know actually what is the classful IP addresses. So classful IP address, again we have the class A, B, C, D and E, but we have to have very good understanding on class A, class B and class C. Okay, so now let's know how actually the computer separate computer identify which part of a IP address is the network address and which part of or what part of the IP address is a host address. So we need to know that, and this is done basically by using the mask. So or network mask or subnet mask. So subnet mask is basically used to know the what part of a IP address is used for network address and what part of an IP address is used for host address. So the default subnet mask for class A is 255.0.0. Default subnet mask for class B is 255.255.0.0 and default subnet mask for class C is 255.255.255.0. And I will show you by using a small lab so on how actually the default subnet mask works in computer in the communication networks. Okay, so now what is the use of this subnet mask or this network mask, or how actually computer understand by using this mask what part is the network address and what part is the host address. So now again, for example, we have an IP address 192.168.10.10, and if we convert it to the binary, so we will get this binary number, right? And then this is 192.168, so that means this is default is a class C network address, and the default class C subnet mask, right? Default class C subnet mask is 255.255.255. And if we convert this to the binary, so all these are 1 and this is 0. So what computer actually do? Computer do the binary AND operation between the IP address and the subnet mask. So when they do this bitwise AND operation, so then they get these numbers, right? And this part they identify as a host part, and this part, which is all are 1 in the subnet mask, is considered as a network part. So subnet mask actually define which part is the network part and which part is the host part. So all the ones are actually saying to the computer, okay, these all ones means that this corresponding part of the IP address is the network address, and all of this 0 is saying, okay, this corresponding part of the IP address is actually the host part. So by doing this bitwise AND operation, computer actually know which part is the network address, or a network device actually know which part is a network address and which part or what part of a IP address is the host part. Okay, so now for example here, let's see. In this case, consider we have IP addresses of the class C network, right? So, and we assign them the different IP address to different computer and laptops, and we have a router, and they all the computers and laptops are connected through the switch. So now the devices, computers or the routers need to know what part is the network address and what part is assigned for a specific host. So if we consider 192.168.1.0, and that means if this is our network address, this is network part and host part, that then if we convert it to the binary number, that means all 0 is actually saying all 0. If this part is all 0, then other part is the network address, and all this host part all are 1. That means this address or 192.168.1.255, this is the broadcast address within this domain. Okay, so 1 is the network address. So the network address is 192.160.1.0, and the broadcast address is actually the host part are all 1. When the host part all are 1, that is the broadcast address, and when the host part are all are 0, that called the network address. And if the host part is other than these two, that means there is a combination of 1 and 0, that is an specific IP address for one of the devices. Make sense, right? So now we know how actually we can analyze, how we know the what part is the network address, broadcast address, and the IP address of a specific host. So now let's see two more things. One is called the first IP address and the last IP address, or first usable host address and the last usable host address. So the first usable host address is basically one more than the network address. So we saw in the previous slide, like here we said the all are 0, so which is the network address. So one more than the network address, so 1 so which is the first host address, and 1 less than is the broadcast address. So broadcast address was 255. So 1 less than 255 is 254, which is 1111110. So which is the last host. And that means the range of IP addresses, a range of usable IP addresses of this network 192.160.1.0 network. Okay, so the next thing is we need to know about the concept of private IP address. Private IP address. So why we need the private IP address, and what is the private IP address, or what is the key feature of private IP address? So one of the key feature of the private IP address is this IP address are not globally unique. That means this IP address, the same IP address, can be used by different organization or different colleges, different universities, different school can use in the different part of the world. So the same IP address may be someone using in Australia, and again the same IP address might be using somewhere in the USA, right? That means they are not globally unique. And another key attribute of this private IP address is not globally routable. That means the IP address cannot travel through the internet from one end to the another end of the this planet, right? So we cannot use private IP address to send something, for example, again from China to South Africa, right? So we cannot use it. So that means this IP address cannot travel through the internet. But one very good advantage of private IP address is actually save the valuable IP address, because IPv4 address, we said, is very limited, 4.3 billion about, right? So but we need now way more IP addresses, and that's why the IPv6 actually we have the the newer version of the IP addresses, and we'll talk about IPv6 later in another video. Okay, and so the private IP addresses, in each class we have some private IP addresses. For example, in class A we have private IP address range is 10.0.0.0 to 10.255.255.255. So these are the IP addresses we can use as a private IP address in class A. In class B we have again another range of IP addresses, so 172.16 to 172.31, and then .0.0 to 255.255. So we have around 16 networks in the class C, so 16 to 31, right? So private IP address. And then the class C, we also have 192.168.0 to 192.168.255, then 0 and 255. So in this case we have even more network, like around 255 networks, which and then the corresponding IP addresses is private IP address. So we can use many organization, many academic institution can use. This is duplicate, like someone in here for example, one part in the USA or Australia or India or China or Brazil, right? So they can use it, but these IP addresses are not travel through the internet. Okay, they cannot globally routable. So now I think we get a very good idea on the classful IP addresses. So again, the classful IP addresses is fixed, right? Then another concept came. So to make the IP addresses more flexible, more user friendly, more less wastage of the IP addresses, right? So then the new concept is called the classless addressing or classless inter-domain routing. So again, the classful IP addresses is fixed, right? We have fixed class A, class B, class C, class D, and the class E. And the class A has only the 8 bits is for network address. Class B only 16 bit for network address. Class C is 24-bit network address, right? So these are the fixed. So 24, 16, and 8. Then the new concept came to make the IP address, the concept, more flexible, more to reduce the wastage of IP address, and it called the classless addressing. So idea of the classless of addressing is saying, instead of considering class A, class B, class C, let's have any block of IP addresses from all these IP addresses. So all of these 4.3 billion IP addresses, let's take a consecutive number of IP address, which is we call a block, and we can use it. But when we take randomly any block of IP address from anywhere, how can we know, or how a computer, how a device know which part is the network part and which part is for host? Right? This is the key issue. Then they start thinking, okay, how can we resolve it? So to resolve it, so the new concept is saying, so let's use the slash notation. So the slash notation is used for identifying number of networks. Like for example, x.x.x.x/23. So it means the network address is 23. So previously in the classful, we can only have either 24 or 16 or the 8. So if it is class A, we can have 8. If it is class B, we can have 16. And if it is class C, we can have 24. But now when we say the classless, then we can have any size, any number after the slash. That means the size of the network could be any bit. So is not fixed like the 8, 16 or 24. It could be 23, it could be 6, it could be 15, it could be any number in between. So when we say the 23, so that means the network part is 23 bits and the host part is 9 bits. So all together is 32 bits. Okay, so now let's see another example. So here, for example, we have 192 then .160.1.66/26. So that means 26 bits for the network part and 6 bit for the host part. So what should be the mask in this case? But previously we know the default mask, class A, class B, class C. So the class A 255.0.0, class C 255.255.255.0. But now that this default mask will not work anymore, right? So because this is any number could be the network address. So we need to know what is the mask of this network. So So if we say 192.160.1.66, and what should be the mask for in this case, right? So if we convert in this all in the binary numbers, so all the 26 bits should be 1. So previously, if it is class C, like 192 is a class C, if we don't use this notation, so the default mask was 255.255.255.0, but the default mask is no more useful. Now we have to find out the mask. So like this all are 1, this is 1, this is 1, and 2 more bits, 24 and then 25, 26. So the 2 more bits is also 1 and 1. So 1 and 1, then all 0 is 192. So now the mask of this IP address, this IP address is 255.255.255.192. So in case of classless, we have to be careful about network mask. We have to find out the mask. Okay. So the network address in this case, because this part is network, so all others are 0. So if all others are 0, so the network address is 192.160.1 dot this 1 and all are 0, 1 and all are 0. That means 64. See, network address is also different. If we say the default network in class C, which is 192.160.1, but now we are using the classless, so now the network address is here 192.161.64, and the mask is 255.255.255.192, and number of hosts in each subnet is 2 to the power 6 minus 2, which is 62. So that means we are not considering the broadcast address and the network address. That's why we are subtracting 2. Okay, so that 62. So let's see another example. So consider we have an IP address 180.120.5.66/22. So that means 22 bits is for network and 10 bits is for host. So now what is the mask for this network? So again, let's see in the same way 180, 125 and 66. If we convert to them in a binary, and our mask is 22 bit, so the 8 plus 8, 16, and then 17, 18, 19, 20, 21, 22. So this 22 bits is all are 1, and the remaining part is all are 0. So that means that this all 1 is 255, this is all 1 is 255, and this is 1 1 1 1 1 1 is 252, and this is 0. So the new mask is 255.255.252.0. So and the network address in this case, so this all are 0, right? So and this part is the network. So if this part is the network, so from here, in here 2 bits and here 8 bits, all the 10 bits are the host part. So what is the network address of this IP address? The network address of this IP address is 180.120.4.0, because 100 is 4 and this part is 0. See, so now the network address is 180.120.4.0, and the number of hosts we can get in each network of this network is 2 to the power 10 minus 2, so which is 1022. Okay, so let's see a quick example or quick lab, so that I can show you the default gateway, and if it is not default gateway, so what should we have to do. So let's create a simple network. For example, I have a switch and I have I want to connect two laptops in this network through the switch and connect them. Laptop 1, laptop connected. So let's say this is the laptop 1. It's laptop 2, and this is laptop 1, and connect this with first Ethernet 2, and here first Ethernet. So now if I go to the configuration of IP configuration, so let's give the IP address is 192.168.10.1, right? And if I click here, so you can see that subnet mask is 255.255.255.0, so which is the default subnet mask. Like for example, if I say this is 10.160, so then if you come here and if you look at this, let's do it on 10.10.10.1. So now if we do here, so you can see this is the 255. That means this is a class A network. So the computer or the devices, they bring the default mask, right? But if you look at, if you consider, no, my IP address is something different, like as we saw in the previous example, for example 180.160.10. For example 10.21, but I don't want this is the default subnet mask. So like again, write to 180.160.10.11. so you can see the default subnet mask, but I don't want this is the default subnet mask. So consider the subnet mask in is /22. That means in that case you have to write 252.0. so you have to configure your subnet mask manually, right? Because this is no more now the class B. Now we are looking at /22. So when we say the /22, and in that case we find it here, the /22, the IP address, so which is the subnet mask, is 255.255.252, right? So we can assign the IP address is this, right? Then again, now if we assign the IP address to the laptop 2, so next IP configuration, so what should be the IP address again? 180.160.10. for example 12, and then the subnet mask is not 255.255.0.0. subnet mask should be 252, right? So now they both are in the same networks, and let's see, they can now communicate to each other. Let's see, we can communicate, we can ping to the first computer, ping 180.160.10.11, right? So they can communicate each other. But if you do not configure the subnet mask correctly, they cannot communicate each other. This is very important concept to understand the mask, right? Whatever you do with your network, you ultimately have very clear idea on IP address and subnet mask. So in this video we discuss about the classful IP address, classless IP address, how to find the host part, network part, and by using the mask, and how we can define the mask if it is the classless IP address. In the next video, I will talk more details on the subnetting concept, which is another very important concept on networking. So I will discuss in the next video the subnetting for IPv4 address. So thank you very much for watching the video.